This video is about the uncertainty principle. As with many concepts in physics, we could spend hours discussing the uncertainty principle. In this video, we'll only focus on those aspects of this principle that are important for the IB Physics course. As a basic starting point, let's state that the uncertainty principle arises because, as we have seen earlier, matter behaves both as a particle and a wave. According to the uncertainty principle, some properties of a system cannot be precisely determined simultaneously. Let's explore what this statement means. When we say some properties, we mean pairs of properties, for example, position and momentum, or energy and time. Let's discuss the uncertainty principle for position and momentum. The principle states that we cannot precisely determine both the position and the momentum of a particle at any given moment. So, for example, if we know the position of a particle very precisely, in other words, when the uncertainty in the particle's position is very small, the uncertainty in the particle's momentum will be large. This is also true the other way around. If the uncertainty in the momentum is small, then the uncertainty in the position will be large. Here is the equation that describes the uncertainty principle for position and momentum. These are the variables in the equation. H over 4 pi is a constant, and what the equation tells us is that the product of the position and the momentum has to be equal to or larger than h over 4 pi. Therefore, as the uncertainty in one of the variables decreases, logically the uncertainty in the other variable has to increase. It is important to note here that the uncertainty doesn't arise because of measurement precision, but it is an inherent characteristic of a quantum system. Let's move on to the uncertainty principle for energy and time. This principle states that we cannot precisely determine both the energy and the lifetime of a quantum state. As an example, consider the excited states of an atom. The lifetime of an atom in an excited state is very short. When the atom returns to the ground state, it emits energy in the form of a photon. You might recall that we learned about this in subtopic 7.1. The uncertainty principle tells us that there is an uncertainty in the amount of emitted energy and the time during which the atom is in an excited state. The formula to express this concept looks like this, and here are the variables that are present in this formula. Once again, you can see that since the right-hand side of the formula is constant, as the uncertainty in the energy decreases, the uncertainty in lifetime must increase, and vice versa. And just a final note that on IB Physics exams, it is almost always the position and momentum formula that comes up. It is often combined with one of the other momentum equations from subtopic 2.4. This completes our discussion of the uncertainty principle. In the next video, we'll learn about quantum tunneling.